The other type of corrosion is localized corrosion. So localized corrosion is a corrosion phenomenon concentrated at some specific sites of a metal surface, which is very small regarding to the whole surface of the metal that does not corrode. So it's the pitting and the crevice corrosion. So again, in the example of the cathodic protection, when we're trying to make all the surface behave like a cathode, if we fail to make all the surface as cathode, and we have some anodic areas, these anodic areas will corrode very rapidly, and these anodic areas become the localized corrosion nucleation, the pit. For example, if we have we have a coating in our surface and the coating breaks locally, then this is an anode, a small anode that will corrode the entire, it corrode very fast in comparison with the other sections. So pitting, then I will explain the mechanism. So the pitting is considered to be autocatalytic in nature. That's the reason why it's so fast. Once the pitting starts to grow, it could be very aggressive, and the kinetic of the corrosion, it could be very fast. So the conditions are altered such that the further pit growth is promoted. Inside of the pitting, like if we are moving something, this is some environment happen, some environment is not the same the environment in outside than the environment inside of the pit. So the environment inside of the pit, it becomes autocatalytic, and this is exactly what is making the corrosion go so fast. In terms of the mechanism, first of all needs to be damaged the protective oxide film. It could be the protective oxide film or the protective coating, or it could be a piece of something else that is sitting there and it causes an under-deposit corrosion. As I said, the protective coating or the presence of non-uniformities in the metal. So these things are promoters of the pitting corrosion. How the pitting corrosion is in terms of the chemistry happening. In the environment, for example, here we have oxygen, we have chlorides, we have sodium there. So these are dissolved in water. Imagine this is water. Now, we have a hole, we have an anomaly. This is not, initially this is not big, but this is an anode there. So the anode is corroding. So the corrosion process, is going metal plus into the solution. Metal plus goes to the solution. Electrons travel, or electrons remain in the metallic path and form there the electrons at the surface there. Oops. Those electrons are at the surface, going to the surface. Electrons then are required when oxygen reduce. So oxygen take electrons, oxygen plus 4 electrons make OH there at the surface. This OH can take the M plus that is there, that is now saturated, the M plus there, M plus, and form scales there. Because we have too many pluses, M plus, M plus, M plus, M plus, M plus, this needs to be neutral, and that's electroneutrality. We have now too many M pluses or pluses, the electrons, the charge is not balanced, then the chlorides start to go inside the hole. When the chlorides go inside the hole, then this corrosion process keeps going, because now it's a demand of M pluses in this hole. And this is the autocatalytic mechanism of the pitting. So we have an anode that corrodes fast. It's producing ions in the solution, electrons through the electrolyte to the metallic, electrons through the metallic path. The OH or the oxygen is taking electrons and form OH as part of the reaction. And the chlorides, which are negative charge, are just balancing whatever is inside of the pit, making this autocatalytic reaction very fast. So local pit environments become depleted of cathodic reactant. Pit cavity becomes rich in cationic species. That's basically the M+. The cathodic reactants are the chlorides. Migration of ionic species like chloride is possible to maintain electroneutrality and hydrolysis of water to form hydrochloric acid. So now the pH there and the potentials there are so different that the potentials at the surface and the environment at the surface, that the water becomes acidic. So this guy goes very quick in corrosion. There are some incidents, as we discussed when we talk about the stainless steel. The stainless steel are prone to have pitting because the passive layer can be depleted, can be lost, and then when the passive layer is lost, is compromised, then we can have pits all along the line, and this is how it looks, the pitting all along the line.